Hi, this is the 6th video for week 2 trigonometry. This is the 6th of 10 videos for week 2 and covers finding the length of unknown sides. These videos are intended to help you to work through the online content for week 2. We recommend that you watch this video with your pen and paper and pause at the relevant times to try the examples for yourself. If we know an angle and one side in a right angled triangle, then we can find the length of either of the other two sides using a similar process as before. So our step 1, we mark on the triangle the required side that we need to know. Step 2, we name only our sides of interest. Step 3, we use our SOHCAHTOA to decide which ratio to use. And step 4, we write the appropriate equation and solve it. So looking at example 10, we want to calculate the length of XY here in the triangle. So we know our XY, we know this angle here is 30 degrees. So here we know 5.5 for the length here, which is our opposite. Here XY is our adjacent. We have SOHCAHTOA. So here we have adjacent and opposite. That is our tangent ratio. So we know our tan of 30 degrees here is equal to opposite 5.5 divided by adjacent, which is what we don't know. We'll call it x at the moment to make it easier to write. So we don't know what this x is. Here we're going to have to do some rearranging. So we've got divided by x. If we multiply both sides by x, here our x's will cancel, so we get x tangent of 30 degrees is equal to 5.5. So we're getting better, but we still don't have x by itself. So we're going to divide both sides by tangent 30 degrees. So these will cancel, and we end up x is equal to 5.5 divided by the tan of 30 degrees. So we notice what we've done from the start is switch these two round, our x and our tan 30, our x and our tan 30. So you can take a shortcut with working through. So now we get our calculator. So here we've got our fraction, 5.5 at the top, divided by tan of 30 degrees. We make sure we're in our degrees function. I was in our radians, so here I'm in degrees now, and equals, and here I get 9.5 units there. Looking at example 10. So here we've got this angle here is 35 degrees. We're wanting to find this x, which is our opposite. And here we have our hypotenuse. And we think about our SOHCAHTOA. Here opposite and hypotenuse is our sine ratio. So we know the sine of 35 degrees here is equal to x divided by 152 meters. Here, so we've got our x at the top of our fraction. We've got divided by 152, so to undo that we multiply by 152 and multiply our other side by 152. So they will cancel out and we end up with x is equal to 152 sine 35 degrees. We enter that into our calculator, 152 sine and 35 degrees there, and equals. So here we get x is equal to 87.18 meters. Looking at example 12, we want to use trigonometry to find the length of the base of the triangle. So this base at the bottom of our triangle. And we notice that we've got 16 centimeters and 16 centimeters. We also notice we don't have any right angles here. But remembering when we have two sides the same length, we have an isosceles triangle, which means we can cut this down the middle here and we will have a right angle here, and this angle here will be half of 24 is 12 degrees. So now we're wanting to find the length of the base. So we'll call this part, we can find this part in our triangle here, x. So here we've got 12 degrees, this is our hypotenuse, and this is our opposite. And so that is our sine rule. We know sine of 12 degrees. Here is our opposite divided by the hypotenuse is 16. Multiply both sides by 16. cancel, cancel. X is equal to 16 sine of 12 degrees. So we put this into our calculator, 16 sine 12 degrees here, and equals. So here we've got X is equal to 3.33 centimeters to 2 decimal places. But that only gives us this X here. We're wanting the base of our whole triangle all the way across. And because it's isosceles, this length is also X. This one and this one are the same length. So our base will be 2 times X here. So we times our answer by 2 here and equals. And so here I've got 6.65 centimeters for the base of that triangle.